So first of all, let's have a look at it. Area under a curve. Now, way back in one of the videos, I did say that definite integrals represent the area between a curve and the x-axis. It's the area under the curve. Okay, now I've got a definition here of what a definite integral is. So we integrate, we sub in the upper and lower limits. And here's now a picture at the bottom of what we're talking about. We've got this function y equals f of x. From x equals a to x equals b, that's our two limits. So what the integral really represents is the area under the curve, between the curve and the x-axis. It's the area under the curve and above the x-axis. We've got the area under a curve, so find the area between the function and the x-axis, between x equals 0 and x equals 5. Now in this example we've got the function f of x equals x. It's just a straight line, y equals x. But remember, straight lines are just special types of functions. So I'll put in the graph x is 0, x is 5, dotted line comes down. So what I'm really trying to find is the area of that rectangle. So I can use algebra. I've got area equals a half the base times the height, which equals a half times 5 times 5. I'm getting y is 5, the height of the graph, and that equals 12.5 square units. Or we can use calculus. Now we've just told you that integration just calculates the area between a curve and the x-axis. So let's just try it. So the area could also equal the integral from x is 0 to x is 5 of x dx. So area equals is a half x squared from x is 0 to x is 5. Sub in the limits and evaluate, and that also gives me 12.5 square units. Okay, so just a proof to you that integrating a function between two limits gives you the area under that function between the function and the x-axis. Right, let's try another example. So look at this graph now. I've got g of x equals x plus 4. It says find the area between the function and the x-axis between x is 0 and x is 4. So x is 0 is here, so when x is 0, y equals 4. When x is 4, y equals 8. It's a bit more complicated now, but it's still just a straight line. Now I could just use algebra. I could split that up into two shapes. I've got a triangle at the top plus a square at the bottom. I can work out the area 1 is a half the base times the height, which is a half times 4 equals 8. The bottom area is length times breadth equals 4 times 4 is 16. We can add them together. 8 plus 16 is 24 square units. That's using new geometry. Or I could use integration, I could use calculus. I could say the area equals the integral from 0 to 4 of the function x plus 4 with respect to x. It's an easy enough integral. I've got a half x squared plus 4x from x is 0 to x is 4. Sub in the limits and evaluate. I've also got the area equals 24 square units. Here's another example. Okay, I've got area under a curve, and this is when we really need calculus. We can't do it from some simple geometry. So it says now find the area between the function and the x-axis between x is 0 and x is 2. I've got the function h of x equals x squared, so this time it's a parabola, it's a quadratic. Okay, I've got the limits in, x is 0 to x is 2, so it's the area between the curved surface and the x-axis. Can't use algebra, so we now need to use our calculus. So the area equals the integral from 0 to 2 of x squared with respect to x. Integrating, I get a third x cubed from 0 to 2. Sub in your limits and evaluate, and that tells me the area equals 8 over 3 square units. Right, example 1. Now you're on your own. Okay, the graph of y equals x squared minus 4x is shown below. Calculate the shaded area. Okay, you need to be able to understand that calculating an area between a curve and the x-axis, then you need to integrate. They're not saying to integrate, you need to know that. So the key steps are down the bottom. Again, we just prepare, integrate, sub in limits and evaluate upper minus lower, and simplify your answer fully. So we've got the integral from 4 to 5 of x squared minus 4x with respect to x. That gives us a third x cubed minus 4x squared over 2 from x is 4 to x is 5. Now you sublimits and evaluate upper and minus lower. Now in this case you would always simplify that first. 4 over 2 x squared is just 2x squared. Okay, so it's simplified form now. Put in your 5, x is 5, put in x is 4, evaluate and subtract. We get 61 over 3 minus 18, which equals 2 1/3. Now, I missed it a step there, but you take the time then to make sure you understand how do you get from 61 over 3 minus 18 to 2 1/3, and make sure you fully understand all those steps. So that now tells us that the shaded area they've asked for is 2 1/3 square units. You must answer the question. Right.
Example 2. Evaluate the integral 3x squared plus 4 between the limits of 1 and 2 and draw a sketch to illustrate the area represented by this integral. And you can see this is worth 5 marks. So the first thing we need to do is we need to integrate 3x squared plus 4 with respect to x. So the first term will become x cubed and the second term will be plus 4x. Now we need to sub the limits and evaluate. So remember, it is your upper limit, subtract your lower limit. So inserting the number 2, 2 cubed plus 4 multiplied by 2. And then inserting the lower limit, 1 cubed plus 4 multiplied by 1. So our first bracket becomes 8 plus 8. Our second bracket is 1 plus 4. Then removing the brackets, we'll have 16 subtract 5, and the answer is 11. So here we have 11 square units. And drawing this integral, we'll have 3x squared as a parabola. Plus 4 has moved it up 4 places. And between 1 and 2 is between the x coordinates of 1 and 2, which you can see now from the diagram. Now try this example on your own. Please pause the video. And the solution for A, the first thing we're going to do is we're going to integrate 4 minus x squared to give us 4x minus 1/3 x cubed between the limits of 1 and 2. We'll then have to insert our limits. So that gives the line 4 times 2 minus 1/3 multiplied by 2 cubed. Subtract 4 times 1 minus 1/3 multiplied by 1 cubed. Simplifying the first bracket, we will have 8 subtract 8 over 3. The second bracket will be 4 subtract 1 over 3. And removing the brackets will give 8 minus 8 over 3 minus 4 plus 1 over 3. Combining the whole numbers will give us 4. The fractions will be minus 7 over 3. And 4 subtract 7 over 3 is equal to 5 over 3. So the area is 5 over 3 square units. Part B is to draw a sketch to represent this. So we have, again, another parabola. So it's a negative x squared add 4. So our turning point is 0, 4. And then we were to find the area between x is 1 and x is 2. So this is represented here by our dotted lines.
We'll learn to find the area under a curve, and the integral of a function represents the area between the function and the x-axis. Our key steps are to prepare to integrate and simplify fully, and write a statement that the integral equals the area in square units.
Now try this example on your own. Please pause the video. And the solution for A, the first thing we're going to do is we're going to integrate 4 minus x squared to give us 4x minus 1/3 x cubed between the limits of 1 and 2. We'll then have to insert our limits. So that gives the line 4 times 2 minus 1/3 multiplied by 2 cubed. Subtract 4 times 1 minus 1/3 multiplied by 1 cubed. Simplifying the first bracket, we will have 8 subtract 8 over 3. The second bracket will be 4 subtract 1 over 3. And removing the brackets will give 8 minus 8 over 3 minus 4 plus 1 over 3. Combining the whole numbers will give us 4. The fractions will be minus 7 over 3, and 4 subtract 7 over 3 is equal to 5 over 3. So the area is 5 over 3 square units. Part B is to draw a sketch to represent this. So we have, again, another parabola. So it's a negative x squared add 4. So our turning point is 0, 4. And then we were to find the area between x is 1 and x is 2. So this is represented here by our dotted lines.